Okay. Today we are going to discuss about voltage controlled oscillator. So voltage controlled oscillator, IC, it is available in the form of IC. Its name is 566. Okay, 566. What is 555? What is the IC 555? 566 is voltage controlled oscillator. What is the functionality of IC 555? You can respond either in chat box or unmute and respond. Better to respond in chat box, whatever you like, no problem for me. 566 is voltage control oscillator. What is 555? What is 555? I think you have responded in chat box. Yes, 555 is a timer. Very good, very good. Right. Why you are taking a lot of time? Yes, right. 555 is a timer. Then 566 is VCO. What is 565 IC? What is the functionality of the IC 565? 566 is VCO. And what is the functionality of IC 565? Very good, very good, very good. PLL, very good. Bindusri, Geeta, all that. Okay. So it is phase locked loop. Okay. Yes, 565 is a phase locked loop IC, PLL IC. Very good, ma. Edmund Roy and Revati, all that. Okay. Now we have studied about various analog ICs, right? 555 timer, of course 741 in the beginning we have studied 555 timer, then 565 PLN, then this is 566. So whenever we learn about any IC, we see its pin diagram, right? So let us see the pin diagram of this 565, 566 voltage controlled oscillator, right? And before we learn about this voltage controlled oscillator, let us see there is other name for this voltage control oscillator. I think we have come across this voltage control oscillator in 565 IC. That means when we discussed about 565 or PLL functional diagram, our basic phase locked loop functional diagram, we came across this voltage control oscillator. So 565 PLL IC, or otherwise PLL, consists of mainly three blocks. First one is the phase detector or phase comparator. Second one is the low pass filter, and the third block is the voltage control oscillator. So what is the function of this voltage control oscillator? This VCO gives the oscillations of required frequency. That means it gives output frequency which is proportional to the input voltage, which is proportional to the input voltage. That means when you give input voltage, certain voltage, then this voltage control oscillator VCO gives frequency signal of certain frequency which is proportional to the input voltage. That means the output frequency of this oscillator is controlled by the input voltage. Otherwise, we also call this input voltage as control voltage, because this control voltage is controlling the frequency of the oscillator, controlling the output frequency of the oscillator. So therefore, this VCO is also called as voltage to frequency converter, right? So this VCO is also called as voltage to frequency converter, right? So where this voltage to frequency converter is required, we have seen some FSK demodulation, FSK modulation, all that. Okay. In FSK modulation or demodulation, binary signals are converted into certain frequency and then they are transmitted. Okay. So that means for binary 1, the one frequency is assigned. For binary digit 0, another frequency. That means digital data is converted into respective carrier frequencies and then they are transmitted, right? So what is the input? Input is some voltage, some DC voltage, either 0 volts or some logic 1 equivalent to 5 volts or something, whatever voltage we have here. Then the voltage control oscillator will generate frequency. So we have seen how this frequency is obtained at the output. Okay. So finally, some applications require uh, voltage to be converted into frequency. So such applications we use this VCO. So therefore, we call this as voltage to frequency converter. VCO is also called as voltage to frequency converter. This is a voltage controlled oscillator. Oscillator generates oscillations of a particular frequency. So it depends on the control voltage that we apply. That means input voltage is controlling the output frequency of this oscillator. Therefore, we call this as voltage controlled oscillator. Okay, now if you observe this pin diagram, right? We know when we talk about any IC, that means any IC, it's a pin diagram, it's a block diagram, then its electrical characteristics, all these we study. So similar to that, let us see the pin diagram of this 566 IC. It is a 8-pin IC. It is an 8-pin IC. And one more point, what you have to remember here is the voltage control oscillator gives two different types of outputs. Okay, one is square wave output it will produce. Other one is triangular wave output it will produce. Therefore, this VCO has one input and two outputs. Okay, so it will produce two outputs. How it is able to produce two outputs, we will see, we will understand when we look into the block diagram of this VCO in the next slide. Right now, the VCO has one pin number 1 as ground pin and one pin, 8th pin is as VCC, right? So it is an 8-pin IC like our 555 timer. So first pin is ground and 8th pin is VCC. And then a second pin has no connection. Second pin has no connection. Then this VCO has one input pin and two output pins. Right? What are the output pins? Pin number 3 and pin number 4 are the output pins. Pin number 3 and pin number 4. Pin number 3 is square wave output and pin number 4 is triangular wave output. Whatever waveform you want, that there you can give your respective connections. So you can pick square wave output from pin number 3. You can pick triangular wave output from pin number 4. So these are the pins. So left side all pin diagram pin numbers are over, right? And then right side you see this is a control voltage, right? So input to the VCO, input to this VCO is applied at pin number 5. So pin number 5 is the input pin, that is modulation input or control voltage, whatever you say. Then only two other pins are pin number 7 and 6, where you have to connect externally one resistor R1 and one capacitor C1. So this is the pin diagram of this VCO. VCO has one input and two outputs. So input pin is the 5th pin and output pins are 3 and 4, and then it requires one VCC and ground. So VCC 8th pin and ground first pin and second pin has no connection, and only two other pins are the resistor connection and capacitor connection. Okay, so this is very easy to remember. So all of you please learn this pin diagram of 566. Okay, you have learned already 555 and other pin diagrams also. You please learn this pin diagram. It is very, very easy. Then let me ask you one or two small questions on this. Right? I think in the next slide also pin numbers are given. Here also pin numbers are given. Let me ask here. So if we observe the pin diagram of 556, where we give input, to which pin we give input to the voltage control oscillator IC 566. To which pin you apply input voltage. You please respond in chat box or unmute and respond. To which pin you give input voltage to voltage control oscillator. Yes, pin number 5. Very good, very good. Some of you have answered. Yes, yes, very good. Many others also have answered. It is pin number 5. And what are the output pins of VCO 566? What are the output pins of VCO 556? Very good, very good. Right? Pin number 3 and 4. Pin number 3 and 4. And some of you can write what is pin number 3 and what is pin number 4 also. Right? So pin number 3 and 4 are the output pins. Very good, very good. Thank you for your response. So I think by now you have learned this. What is the ground pin? What is the ground pin of 566? I am just hiding the pin diagram so that you might have noted down. Ground pin. Ground pin is some of you are writing pin number 1. Very good, very good. You check once. Yes. Geeta also 1. Very good. Ground pin is pin number 1. What is the 8th pin? What is the 8th pin? What do we connect at pin number 8? Pin number 8. What do we connect at pin number 8 of 566? What do we connect? What is pin number 8 of 566? Yes, voltage supply. Very good, very good, very good. So, what is pin number 2? Pin number 2. Pin number 2. Voltage supply, pin number 8. Okay. So, what is pin number 2? No connection. Very good, very good. So, that means I think you are able to learn what is the pin diagram of this 566. 566 has pin number 1 and 8, ground and VCC, supply voltage. Pin number 2, no connection. And two output pins are pin number 3 and 4, square wave output and triangular wave output. Then modulation input is the input pin. And R1 and R6 are the two pins. I mean, 6th and 7th pins we connect R1 and C1, and 8th pin is ground. Okay, with this knowledge, now let us see the block diagram of voltage control oscillator. The block diagram of VCO, voltage control oscillator. If you observe the block diagram, just you see what is that? The input pin is the 5th pin, modulation input. Output pins are pin number 3 and 4. So square wave output and triangular wave output here. And then to pin number 6, R1 is connected, and to pin number 7, C1 is connected. Pin number 1 is grounded. Pin number 8 is connected to supply voltage. Right? Now let us see the internal block diagram. Block diagram. Just modulations input are control voltage, whatever you say, that is given to a current source. It is connected to a current source. So this current source makes this here you observe downward, right? This current source, it makes this capacitor to charge and discharge linearly, right? Actually, capacitor charges and discharges, charges and discharges. But because of the presence of this current source, the capacitor is allowed to charge linearly and discharge, charge and discharge. Okay, so like that, the capacitor charge discharge gives the triangular wave. Okay, buffer amplifier we know, just for impedance matching, we connect buffer amplifier here. So therefore, we say the capacitor charging and discharging gives triangular wave. Again, the same current source is connected to a Smith trigger. So Smith trigger gives square wave as its output. square wave as its output, and through buffer amplifier, this square wave is connected to the output. So like that, it is possible to have square wave and triangular wave from the output of the voltage control oscillator depending on the modulating input signal. So this is very, very simple block diagram, right? Now let us see the connection diagram of this VCO. Connection diagram means, we take IC in the form in IC form like this, and outputs we take from here, and respect to other connection diagram, other connection that means external components we connect and we show, right? You observe fifth pin is the modulating input signal, that means we give control voltage. So what is this control voltage? This control voltage is the incoming voltage. Directly modulating input signal can be applied here, but in addition to that, there is some voltage divider is formed with resistors R2 and R3. So voltage, now if you see, if you have V and these two R2 and R3, if they are equal, we will have V by 2 here and V by 2 here. Otherwise, if they are not equal, we will have corresponding voltage drop across these voltage divider resistors. Okay, we select these resistors in such a way to have control voltage varies between 3/4 VCC. That means at least this voltage should be 3/4 that of the supply voltage. Then only modulating signal can be received, and this modulating VC can be between VC can be between 3/4 VC to VC. That means 3/4 V to V. That means supply voltage. If supply voltage is V, at least 3/4 voltage, 3/4 times of that supply voltage should be available as control voltage. Then only your VCO will be working. Okay. So like that it is applied, and therefore in order to have that voltage, what we do is we maintain a voltage divider resistors here. So that voltage will be superimposed. That means this modulating input signal will be superimposed on that, and this VC is always maintained between 3/4 supply voltage to more than 3/4 supply voltage, we can say, right? So like that, the control voltage is applied at fifth pin, and this is the purpose of two voltage divider resistors R2 and R3. Then one small capacitor here. Then R1 is connected at sixth pin, and C1 is connected at seventh pin. This R1 and C1, they determine the output frequency. They determine the VCO gives square wave or triangular wave, but with what frequency means depending on the components you select, and depending on the supply voltage you give, and depending on the control voltage you have here. So F0 is given by 2 into plus V minus VC. That means the difference of these two divided by R1 C1 into that supply voltage. So one more point that we have to keep in mind is always manufacturers they design any IC for specific functionality, right? So that time they give some recommendations. So always it is recommended to have R1 value between 2 kilo ohms to 20 kilo ohms, 2 kilo ohms to 20 kilo ohms. Okay, so this is the connection diagram, and from pin number 4 and 3 we take output. So pin diagram, if you remember, and all these from VCC to ground, if you remember, two voltage divider to maintain control voltage greater than 3/4 supply voltage, we will maintain a voltage divider here, and then modulating input is applied at fifth pin, and sixth pin R1, seventh pin C1, then third and fourth pins output pins. So like that you can have draw this connection diagram of VCO. Then if you observe the output waveform, always the output is either square wave or a triangular wave. If you observe this magnitude, the typical the typical amplitude of triangular wave is 2.4 volts peak to peak, right? So for this triangular wave, the amplitude is 2.4 volts peak to peak for 12 volts VCC, right? For 12 volts VCC. Similarly, the square wave typical value, that means typical output magnitude is 5.4 volts, 5.4 volts from peak to peak. Okay, so like that, the amplitude of output triangular wave and square wave is 2.4 volts and 5.4 volts peak to peak from this voltage control oscillator IC, which is also named as IC 566. IC 566. Okay, so this is what about the connection diagram and functionality of this, and then let us see the applications of VCO. Applications of VCO. Most of the time, in your previous papers, what are the applications of VCO is repeatedly asked as short answer question. Short answer question means not so simple, 3 marks. Okay. So now let us see on the let us concentrate on the applications of VCO. Applications of VCO. Right. These VCO, otherwise these VCOs are used in converting very low frequency signals into audio frequency range. That means if you have amplitude signal of amplitude with some value and very low frequency. Low frequency signal means time period is high. Okay, 1 by t equal to m. So very low frequency signals, if you want to convert them into audio frequency, then we have to use this voltage controlled oscillator. Okay, so these voltage controlled oscillators are commonly used in converting low frequency signals into audio frequency range. Low frequency signals into audio frequency range. So where we have these low frequency signals, right? So low frequency signals such as EEG, right? So electroencephalogram, right? And then electrocardiogram. So I think electrocardiogram, we also name it as ECG, electrocardiogram, ECG. So what is this ECG? I think you have come across this word ECG several times, right? ECG is electrocardiogram. Electrocardiogram records electrical activity of human heart. Okay, cardiogram. So it records electrical activity of human heart. Okay, so you just observe human body, you imagine, and if a patient goes to a doctor, cardiologist, then they will record the electrocardiogram, cardiogram, that is the electrical activity of that person's or that patient's heart. So how do they extract that electrical activity? How do they absorb this? How do they extract this electrical activity? Means there will be some electrodes. There will be some electrodes because directly it is not possible. These electrodes, they will convert this electrical activity of human heart into electrical signals. Okay, so these electrodes will collect these electrical signals from the human heart, and these are very low frequency signals, very low amplitude also, low voltage and also low frequency signals. So these are not possible to that means evaluate or process directly. Therefore, these very low frequency signals are connected to the voltage control oscillator. Then this voltage control oscillator will convert these electrical signals into these very low frequency electrical signals into audio frequency range, and then the signal can be further transmitted over telephone lines, because telephone lines mean audio range, right? Otherwise, they can be used for radio communication for diagnostic purpose. That means for telemedicine, all that directly they can be transmitted over telephone lines, or they can be recorded on a magnetic tape for documentation. If a patient goes to doctor with some heart problem, they will take this ECG, and after that they will give one printout to the patient. They'll keep it in a file and they give printout to the patient. Anytime, next time, if any elderly person or anyone goes for this ECG from your family or from your relatives, you just observe what is the that means how the ECG looks like. Anyhow, you are going to study about ECG, EEG, and many other biomedical equipment in your next semester, that is in another subject named biomedical engineering. Okay. Now here we are studying about the applications of VCO. These VCOs are commonly used in converting low frequency signals into an audio frequency signal. So these, for example, if we take ECG, and we'll come across this EEG little later. So ECG and EEG signals, they are of very low frequency, and these low frequency signals are converted into audio frequency range by voltage controlled oscillator. After that, these audio signals can be transmitted over telephone lines, or they can be communicated via radio communication for any communication for diagnostic purpose, or these audio frequency signals can be recorded on a magnetic tape for documentation. So whenever you go, next time when the patient goes, they will take, where is your previous ECG? Then for reference, this will be kept as a document in their file, and that can be referred in future. So that means to have all this process, that means in order to transmit over telephone lines, or to communicate over radio communication for diagnostic purpose, or to record on magnetic tape for documentation, these low frequency signals are not possible. Therefore, the low frequency signals are converted into audio frequency range by using voltage controlled oscillator. Now, how ECG is recording the electrical activity of human heart, the EEG, that is electroencephalogram, records the human brain activity, right? So the electrical activity of brain, will be recorded by electroencephalogram, right? So the outputs of ECG and EEG are of very low frequency and very, very low voltage. So these will be translated, or these will be converted into audio frequency range for diagnostic purpose, right? So for such applications, the voltage controlled oscillator is used, right? You please write all this in your own words in the examination, right? So with this, I can say we have completed this voltage controlled oscillator, right? Then let me just 1 second. Let me stop recording, because all this VCO is over, right?